Thank you once again for watching my video. My name is Mr. Charles Fonike. In this video tutorial, we are still on capacitor. Now, in this video, we will specify on a particular area that we are going to discuss is polarized. Under that polarized, we will discuss on electrolytic and tantalum and super capacitor. So in that case, please, if you like my video, subscribe to my channel, comment and like. Thank you once again. Let's start. So in that case, some capacitors such as electrolytic capacitor, tantalum, and supermica capacitor are polarized capacitor. Polarized capacitor, remember, which I have treated this polarized capacitor before in a different video altogether. So I specifically define polarized capacitor in that particular video. If you are not seeing it, please go to Charles Electronics tutorial. You will see what I discuss on polarized capacitor. So in that case, a polarized capacitor, it has two legs, which is positive and negative. It simply means plus and minus. So in that case, what I'm trying to explain here, if you have seen electrolytic capacitor, tantalum, and supermica capacitor, they are all polarized capacitor, which involve the positive and the negative aspect of it. So in that case, a polarized again. That means that they have to be connected in a correct way. In terms of polarized capacitor, it must be that capacitor must be connected in a right way. In a right way, it simply means that the voltage or current will follow one of the leg and pass through the other leg. You cannot connect negative to positive and connect positive to negative. No. If it is the positive, you connect it to positive. If it is the negative, you also connect it to negative. Because if you interchange it, it means that the circuit will not work. It will be given an issue on that particular circuit. So that is why in this particular area, it means that they have to be connected in a correct way. That is what I just explained. The LED are always clearly marked. The lead of the capacitors are always clearly marked on its body, which are what polarized capacitors are mostly electrolytic capacitor. Polarized capacitors are mostly electrolytic capacitor. So just as I said earlier before this time, in terms of polarized, it always contains plus and minus, and that plus and minus it will indicate on the body of the capacitor. So that is just the how you will use to recognize or to identify a polarized capacitor if you have come and across it before. Definitely in this video, I will also show you some finishing product or image of polarized capacitor. And in that case again, the construction of polarized capacitor, they are in different form. They are in different form. They could be in cylinder or they could be in different form altogether. Both are end side, being axial for horizontal mounting or at one side only mounting, which is called radial for standing mounting position. Axial for they also have two legs, but their two legs construction is different from radial. Axial is different from radial, but they are all called a polarized capacitor under electrolytic capacitor. So in that case, let me just show you the difference between the axial and the radial capacitor. Now this is the axial capacitor. Just as I said, it is mounting on in from this place. Now I said horizontal mounting. Horizontal mounting. Why? You can see why it is called a horizontal mounting. Look at it. It has one leg here at other leg here. Why in terms of radial capacitor is different from this aspect. This one I want you to know that in electrolytic capacitor, this one is called the axial capacitor, while the other one that I'm about to show you is called also the radial capacitor. So for you to know it, you have already seen the difference. Let me also show you the radial capacitor as well. This one is radial capacitor. You see how the radial capacitor is. You see there is difference between the radial capacitor and the axial capacitor. This one is different from the other one. You can also see it within your eyes as well. So in that case, both of them, they are all called electrolytic capacitor under polarized capacitor because they have the plus and minus. This indication that you are seeing here is it has its own indication. Here should be negative, then the other side of it is positive. And if you can see that this one is 400 microfarad on in 15 volts. I will also talk about all this in next coming videos as well. So what I'm trying to explain here is I want you to understand what I mean by the positive and the negative. Though I have treated this particular polar capacitor in my previous videos on capacitor, but this one is just for you to understand actually what I am talking about in terms of axial and radial capacitor. Now, in that case, let me still go back to the radial as well, the axial capacitor. Now, you can also see that here is also indicating the negative line. The one that has, I don't know how I'm going to put it, the one that you see the different mark on its body, that is where you can see the negative aspect of it. Now, that is a negative leg. Why you can see that here, let's use this one, the one that has 4,700 microfarad as in a case of study. Now in that case, between these two legs, one is longer than one. The one that is shorter is the negative, while the one that is longer is the positive. And it's obvious that the one that is longer is the one that has the indication that all the bodies are black in terms of this longer leg, which has a longer leg. All the bodies that are black, which the specification of the capacitor is written on its body, while the other one that the leg that is shorter is the one that you can see that it has a different color altogether. So in that case, that one is I am using this as the case of study for you to differentiate the positive and the negative. So in that case, what I'm trying to explain here is the longer leg is the positive leg, while the shorter leg is the negative leg. The same in that in polarized capacitor, for smaller voltages and capacities, polarized capacitors are made out of tantalum are often used. You know, for smaller voltages and capacities, we can also use a tantalum capacitor because tantalum capacitor cannot be compared to other electrolytic capacitor, which we'll be discussing in our next video, where we'll be discussing on the and other capacitor that are involved as well. So in that case, there is difference between the tantalum capacitor and the other previous capacitor that I have just showed you. There is a very big difference here. This one, I believe that it has where this one will be fitted will be different from where the tantalum capacitor will be fitted, because this one is under completely electrolytic capacitor. I know that tantalum is also on that, but what I'm trying to explain here is the voltage that the other one that I showed you will contain will not be the same thing as the voltage that tantalum capacitor will carry. Tantalum capacitor will accept smaller voltages than the other one that I've showed you over there. So they are smaller and look different. Tantalum capacitor, they are smaller and also look different. They are dropped shaped, as in they are different in shapes and smaller in shape as well. Smaller in shape and in every other aspect. On the upcoming video, I will also treat on tantalum capacitor specifically or separately so that you will really understand what I am explaining. So in that case, this is the polarized capacitor picture or diagram for you to understand what I am explaining. Now, in that case, this is an electrolytic capacitor, while this one is super mica super capacitor. Now, under these polarized capacitors, we have electrolytic, we have super mica. Now, under the electrolytic capacitor, we have other area. The one that I've showed you before, the other previous one that I showed you, I used the longer leg and the shorter leg, is called aluminum capacitor. That one is different from tantalum capacitor, is also different from nodule capacitor. So all these things will be treated one after the other, or one by one. So in that in this super capacitor, we also have other one that is under it, which I may not call it, or double layer and the hybrid and the posterior capacitor. They are all under super capacitor. But in this video, we will treat each and every of them one by one. So in that case, I want you to use this to understand if I am talking on any of the capacitor, you know the particular area that I'm talking, if it is the electrolytic or the super capacitor. But presently now, what I'm discussing is the general aspect of it. But the other previous one that I've showed you, being the image of each and every one of them, is electrolytic capacitor, which is under aluminum capacitors as well. So in that case, electrolytic capacitor offer very high capacity. That is the work of it. It offers very high capacity, and where very high capacity is required is where you can see or apply or put an electrolytic capacitor. So in that case, electrolytic capacitor offer very high capacity. The value of electrolytic capacitor is always in microfarad and farad. In that case, in this microfarad and farad, I will treat it specifically because this is the unit of the capacitor which you are meant to understand the difference between microfarad and farad and every other unit under capacitor as well. In times, if you are to convert from one section to another section, you will understand what I'm saying. So in that case, what I'm trying to explain here is this: electrolytic capacitors are always marked with their maximum voltage on its body. Just as I show you, let me go back to it and you will really understand what I mean by that. Now look at the maximum voltage. Look at the microfarad. They are always marked with the maximum voltage that they work with. So like if it exceeds, if current or voltage exceeds it, it means that the capacitor will be destroyed. So that is what I mean by that. So in that case, electrolytic capacitor are generally used in application where very large capacitance values are required. Just I have already explained it before. You can apply or use electrolytic capacitor where a very large capacitance value are required. They are required in various areas of electronics, motherboard, in everything we do in electronics. You can see electrolytic capacitor either in surface mounting device or surface mounting technology or in another form. So in that case, what I'm trying to explain here is this: electrolytic capacitor being under aluminum is where large capacitance are required, is where you can apply or put the electrolytic capacitor under on aluminum capacitor. Now in that case, the electrolytic capacitor have a metallic anode covered with an oxide layer. Electrolytic capacitor, it have a metallic anode covered with oxide layer, generally used as in dielectric. I have treated also dielectric on my previous videos. I treated about permittivity and types of dielectric. I gave names. I treated it very well in that particular video. Please, if you have not seen the video, go back, go to my channel. You will see the video that I have discussed on dielectric material. So in that case, what I'm trying to explain here, the metallic anode covered with oxide layer, generally used as its dielectric. I explained of dielectric, the differences, and how it's named, and how the name of the dielectric is the name of that particular capacitor. And another electrode of capacitor is non-solid or solid capacitor. Non-solid, it could be liquid. And you know, whatever thing that is non-solid could be liquid. It could be also gas. But in this area of it, it could be liquid or also gas, or depending. Why it if involve solid electrolytic, maybe definitely is what we have been discussing so far. Please, thank you once again for watching my video. If you like my video, subscribe to my channel. See you next week. Thank you once again.